Review and preview from lesson 4.2.1. 4-65 says find boundary points for each of the following inequalities. Draw the boundaries on a number line and shade the solutions regions. So this is similar to an equation, but it does have the inequality sign, so it does change things a little bit. But let's start just solving like normal and combining like terms. So I'm going to start with subtracting x, which gives me 2x plus 2 is greater than or equal to negative 6. I'm going to subtract 2 on both sides. So that leaves me with 2x is greater than or equal to negative 8. Divide by 2. So x is greater than or equal to negative 4. Okay. So I'm going to draw just a little sketch of a number line. Sometimes I like to put 0 in the middle. And because that it has the equal to part to the inequality, that's going to be a closed dot. And x is greater than negative 4, so we're going to shade what's greater than. All right, part B. So in part B, I see we have 2x squared minus 5x is less than 12. Let's get this, it looks like a quadratic, so let's get it set as less than 0. So I'm going to subtract 12 on both sides. So that leaves me with 2x squared minus 5x minus 12 is less than 0. I do need to get this factored, so I already factored this over here if you want to take a look at my diamond method. But when I factor, that leaves me with 2x plus 3 times x minus 4 less than 0. And we're going to go ahead and split these up, setting them equal to 0. So I have 2x plus 3 equals 0 and x minus 4 equals 0. So x is equal to negative 3 over 2 and x is equal to 4. Okay. So we do need to make this on a number line and see which way we are going to shade. Okay, so to do that, we need to make a number line and then test a couple of points. 0 in the middle, we have our 4, and our, let's do negative 1 like right here. Okay, so I'll put my open dot right about there. And there. Okay. But to know which way to shade, we're going to test 2 points. So I like to pick sometimes what's on the outside. So let's pick our test points as x equals negative 2 and x equals 5. So we're just going to plug it in and see if it's true or not. So I've got, zoom in, I've got 2 times negative 2 squared minus 5 times negative 2 minus 12 is less than 0. If you solve that out, you get 30 is less than 0. That's false. So that tells me when I put in this point, it's false, telling me from here I need to shade the other way because it's not true if I shade this way. So I'm going to shade, and then I'm going to test x equals 5. So that would be 2 times 5 squared minus 5 times 5. Minus 12 is less than 0, and that gives me 13 is less than 0. That's also false. So that tells me I can't shade over here. That's not true. So I'll also shade this way. And we're done. 4-68, it says solve each equation below. Remember to check for extraneous solutions. Right, so I'm going to start here with rewriting this as y minus 3 times y minus 3. This becomes y squared minus 6y plus 9 equals 2y minus 10. Let's subtract 2y and add the 10. So we've got y squared minus 8y plus 19 equals 0. And technically I should factor this out, but if you take a look and when I'm thinking about how to factor this, I don't really see a way. And when I look in Desmos, I don't see any solutions. So this one is actually no real solutions. Okay, part B, we have an absolute value. So because the absolute value is already by itself, we're ready to do the split up. So we need y minus 3 to equal 2y minus 10, but we also need y minus 3 to equal negative 2y minus 10. So this, if I combine like terms, this becomes negative 1y equals negative 7, so y is 7. Over here, we have to distribute this negative, so it becomes y minus 3 equals negative 2y plus 10. Let's see, so that leaves us with, if we add 2y, we get 3y minus 3 equals 10, so then 3y equals 13. Okay, so then y is equal to 13 thirds. Sorry about the phone. So it does tell us to check for extraneous solutions, so I'm going to test here. So we have 7, so I'm going to plug this back in. Okay, I'm going to take the 7, and I'm going to plug it back in for the y's to see if it's true. Sorry, I'm going to plug it back into our original equation. So I have the absolute value of 7 minus 3 equals 2 times 7 minus 10. So that's the absolute value of 4 equals 2 times 7 is 14 minus 10 is 4, and the absolute value of 4 is equal to 4. Good. 13 thirds is a little bit trickier, but we're going to be fine. So we're going to plug it back into our original equation. So 13 thirds minus 3 equals 2 times 13 thirds minus 10. All right, so in our calculator, one thing that you can always do is take 13 divided by 3 and then minus 3. So that's 4 thirds. Equals 2 times 13 thirds minus 10. That's negative 4 thirds. Okay, the absolute value of 4 thirds is 4 thirds. That does not equal negative 4 thirds. So this one here is extraneous. All right, so let's go ahead and move to 4-69, where we are going to add, subtract, multiply, or divide the following rational expressions, then simplify your expression if possible. So for this one, I see x minus 4 over 2x squared plus 9x minus 5 plus x plus 3 divided by x squared plus 5x. So we need to do a little bit of factoring here. I took this piece, 2x squared plus 9x minus 5, and I factored it over here already, if you want to look at that. So I know this will become 2x minus 1 and x minus 5. And here, this will actually become x times x plus 5. So something I like to do when I am adding them is I like to write them vertically with parentheses. So I've got x minus 4 divided by 2x minus 1 and x minus 5 plus x plus 3 all over x times x plus 5. Okay, so I like to write my arrows and then rewrite them, leaving just a little bit of room. Okay, so I like to rewrite what I already have. I've got the x minus 4 and the 2x minus 1 and the x minus 5 and the x plus 3 and the x plus 5. So we need to have the same common denominator. So if we look here, we've got a 2x minus 1, an x minus 5, and an x. Okay? And check something really quick here. This should be an x plus 5. I apologize. and this right here. Okay, so make sure I wrote that correct over here. This should be a 2x minus 1 and an x plus 5. Sorry about that. There we go. So take a look at that again. We've got this yellow piece here. Okay, we have the yellow. We've got the green. Sorry, this is plus right here. And we've got the purple. Okay, so we need all of those in each spot. So that means I need to get a purple one here, as well as here. And I need to get a gold here, as well as here. So I'm going to rewrite the x and the x here to multiply it. And then I'm going to write the 2x minus 1 here and here. Okay. So now that we have the same denominators, we can pull these together to add. Okay. So it doesn't really matter what order you write them in terms of like the denominator here, as long as they're all being multiplied together. So I'm going to start here with our numerator, x minus 4 times x, and we are adding that to x plus 3 times 2x minus 1. And that'll be all over. It doesn't matter what order. Again, I'm just going to write 2x minus 1 times x plus 5 times x. Okay. And just again, we've got our green or gold, green, and our purple. Okay. As we simplify this, so I'm going to take x and multiply that. So we've got x squared minus 4x. And then when I multiply these two together here using our box method, I get 2x squared minus 1x plus 6x minus 3. Before I rewrite with the whole denominator, let's just simplify that. So put together like terms. That'll give us 3x squared plus 1x minus 3 all over. Now I'm actually going to multiply all of these together as well, leaving us with 2x cubed plus 9x squared minus 5x. Okay, part B. So we've got this, we're subtracting now, and one thing, I'm going to just make this a little smaller so it's not in my way. Okay. All right. So what I did here was I already did the box, and the diamond method to make sure that these were factored out. It's really hard to add these together if you don't do that, okay? So what we're going to do now is write them vertically, because that makes the most sense to me to do it that way. So I'm going to have x minus 2 times 4x minus 3 all over x minus 2 times 2x plus 3. And we're subtracting x plus 2 over 2x plus 3. So something I think you should do first, before we go ahead and totally change everything, take notice that we could cancel these x minus 2's, and now we already have the same denominator. So this can become 4x minus 3 over 2x plus 3 all over x plus 2 over 2x plus 3. We're going to put these together, and we're subtracting. So I'm going to take 4x minus 3, and we have to be really careful here because we're subtracting the quantity x plus 2 all over 2x plus 3. So we do need to distribute that to make it 4x minus 3 minus x minus 2. And simplify one more time. That gives us 3x minus 5 all over 2x plus 3. Okay, part C, we just have to rewrite everything. So we've got x to flip because of this division sign. And then I'm just flipping them around. Okay, and then I'm going to go ahead and cancel whatever I can. So it looks to me like I can cancel these 2x minus 1s, the x minus 7s, 3x minus 4, and x plus 8. So what that leaves me with is x plus 4 all over 4x minus 3. Here I already factored all of these out for you, so we can go ahead and cancel everything that we can. So this becomes the 2m's minus 3 cancel, the m minus 4's cancel, and the m minus 2's cancel. So we're just left with m plus 5 all over m plus 4. Okay, next page here. So we're graphing these 4 inequalities on the same set of axes below. So what you're going to do is type each of these into Desmos so you can graph them. Okay. When you do that, you're going to see that it creates this this rectangle with perpendicular lines. Okay, so you're going to have a point here, here, I think right here. So you need to type these into Desmos. Okay. And take a look for yourself. And then we're going to have 3, negative 4, okay, and 5. Okay, and what's going to happen is you're going to have these lines that go through here, 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 and here. Okay, so it's going to look something like that, and you're going to see this rectangle. Now, it's a sketch, it's not perfect, but it looks more perfect in Desmos if you take a look. So what you're going to write is a rectangle. It's perpendicular lines or slopes. And find the vertices. So if they're accurately drawn, we'll see these points. So we have these pairs. So the points that we see here that are the vertices would be 1, 4, negative 3, negative 3, negative 5, 1, and 3, 0. Okay, we've got a couple more problems here. Yeah, a couple more. 4-74, your family plans to buy a new air conditioner. They can buy the Super Cool X1400 for $800, or they can buy the Efficient Energy X200 for $1,200. Both models will cool your home equally well, but the Efficient Energy model is less expensive to operate. The Super Cool X1400 will cost $60 per month, while the Efficient Energy X2000 only costs $40. So, write an equation for the first one. Well, the cost is equal to $60 a month plus $800. The other one, the cost is equal to $40 a month plus the cost $1,200. Okay, you want to take a look in Desmos, but you're going to see after 20 months. Okay, and then for part D, well, you only use it 4 months out of the year, right? We don't use the air conditioning all the time. So 44 months times what? For 20 months. So how many years? So that'll be 5 years until you have to wait to start saving money. Okay. Then here, find all the points where they intersect. So you want to go to Desmos and look at the points where they intersect, and you will see 1 and 12 and negative 5 and 42. All right, that's all for 4.2.1. Thanks for watching.